Hello everyone, welcome to my channel Similarity. This is the first video of the VEX series that I'll be starting from today. And in this VEX series, I will teach you some VEX setups that you can create in Houdini and use it in your workflows. Also, I will try to keep these setups fundamental and basic to mid level so that even if you are a beginner, you can follow the tutorial and understand how those setup works. Okay. Also, I will try to teach you about the theory behind those setups so that the idea is very clear to you. I mean, how those setups are actually working. Okay. Okay. So in this video, I will teach you a setup like this one, a sphere rotating around another sphere, and also you can rotate it around a point also, or another object, whatever you like. Also, if I change the position of this center sphere here, you can see the other sphere also moves along with it. Okay. Okay, so before I begin creating this whole setup from scratch, let me show you the theory behind it. Okay, so let's say this is or some circle here. Okay, and this is the origin of the circle with coordinate 0 comma 0, right? And let's say we have a point P here at a distance of r. Basically, r is the radius of the circle. Now let's draw a line here and let's call this angle theta. Also, let me draw a line here. Okay, so as you learned in school, the component of this r vector along this axis will be r cos theta, right? And the component of this r vector along this axis will be r sin theta. Okay, so you can see we can deduce the coordinate of point P from here, which is basically r cos theta, which is along this x1, and r sin theta along this y-axis. Okay, so these are the coordinate for the point P, and as we change the value of this angle theta, this point P will move along the circumference of the circle. Okay, so this is the core principle behind the working of that setup that we have seen here, and this is something we will create in the VEX. Okay, okay, so let me open my Houdini here, and let me create okay, I can create this inside here also. Okay, the first thing that we need is to create a add node here. Okay, okay, so let me create a point here. As you can see, we have added a point in the center, this point number 0, right? Now let's create a attribute wrangle here. Okay, so the first thing that we need is our radius here. Let's call it radius. Second thing that we need is a angle. And the last thing that we need is to change our position, because that's the main thing that we want to do, right? We want to change the position of this point such that it moves around a point in a circular path. Okay, that's what we want to create. Okay, so what we have to do is v at the rate p. Basically, this is the position of the point, and we have to set it to set radius multiply cosine of angle comma 0 comma radius multiply sine of angle. Also, you must be thinking why we have added 0 here, because we want to move this point along this xy plane, sorry, xz plane. That's why I have put the coordinate for the y coordinate 0 here, okay, because we are rotating this point in the xz plane, that's why. Now let's see if this is working or not. Okay, the radius part is working. Let's see if the angle is okay. uh, Angle is actually also working. Let me change this to increase the range here, 0 to 360. Also let me change the radius range to 0 to 10, accept. Okay, now you can see this point is rotating around the origin here. Okay, also one more thing we can do here, we can use copy to points so that we can visualize it better. Also let me change the radius here to something like this. Okay, let me see if this is how this is working. Okay, we can add actually here $T. Let me play in the play bar, and you can see, right, our sphere is rotating around the point 0 0 or the origin. Okay. Sorry. Okay, so this is our very basic setup that we have created, and as you can see, we are basically following this thing here, right? We basically are given the uh, point P coordinate r cos theta, r sin theta. Similarly, we have done this similar thing in the VEX also. Radius multiply cosine of angle, radius multiply sine of angle. Okay. Now let's improve this better so that we have more options to work with. Okay, the first thing that we can do is change our origin, because we don't always want to rotate a sphere about this point 0 0. See, we can have some custom points also. So how we can do that? Basically, we can create a vector here. Vector, let's call it origin offset. And we can add this to here, origin offset dot x, because we want the x component here, and for this one we want the z component, plus dot z. Okay, here let's see if this is working or not. Let me change the x coordinate here. Also let me reduce our radius. Okay, I think there's some error here. Let's check what is going on, why this is not working perfectly. Okay, I think this part is right. Radius multiply sine of angle plus origin offset dot g. Okay. Okay, so sorry, we have radius wrong set here. Also, let me add a point at the origin so that so that we can know where the center is. Let's add a point at point on geometry 0 at point origin offset Okay, so basically this is the center here, and let's see if this is working or not. Okay, I think this is working perfectly fine here, and we can change the radius also as we like. Okay. Okay, I think what we can do more here, let's see if I've done something in the previous setup. Yeah. Okay, one more thing. Yes, you can see here, this cosine and sine takes the angle in radians, not degree. Okay, so basically we have to convert this angle here into radians. Okay, and now you can see they are not moving. Actually, they are, you can see the sphere is actually moving, but it is moving. The angle change is very what you can say, that angle change is very small here, because right now we have converted into radians. So what we have to do right now, basically we want to rotate it one full round, right? When our frame ends, right? Basically what we want to do is we want to go one full circle after in 240 frames. So let's see how we can do that. So basically back to Photoshop. Let me create a new layer here. Okay, so what we want to do, we want a point to circle, right? To go to complete one round in 240 frames, because that's how much frame we have here, 240 frames. So how we can create that kind of thing? So as we know, we can use a basic mathematics here. We can write something like $ff upon $f end. Basically, this this things gives us the current frame number. Okay, sorry, current subframe, going from 0 to frame number 240, and this thing gives here the frame number of the last frame, so which is 240 here in our case. Okay, you can see, let me show you in the here. You can see $ff, this basically gives us the frame number of the current subframe, and $f end, let's see where it is, this frame number of the last frame of the animation. Okay, so what we can do, we can create a so basically this will be value 240. So this this thing goes from 0 to 240 and upon 240. So basically the range of this whole thing will be from 0 to 1, right? So if you multiply this value by 360, so the output range of this will become from 0 to 360, right? So that's what we'll do here. But we will write $ff upon $f end. Right now, the range of this thing will be from 0 to 1, because this ff goes from 0 to 240, and this bottom one is, the value is 240. So the range of this whole thing will be from 0 to 1. Now let's multiply it by 360. Now the range of this expression will go from 0 to 360. That's what we want. Now let's see if this is working or not. Yeah, you can see if we move from here to here, you can see one whole round completed. Okay, that's what we want here. Okay, I think this is all we can do here. Okay, so I think this is it for this tutorial, and as you can see, we have created a very basic setup of moving a sphere around a point, and basically there are multiple scenarios where you can use this kind of setup, and you'll find it very useful. Okay, so this is it for this video, and Please subscribe my channel, like this video, and I will post similar videos in future also. So thank you for watching this video. Thanks. Okay, bye.